the second lecture on renewable energy, we are going to discuss about the policy structure that are there in place in order to promote renewable energy. Before we begin with the policy and the structure of the policies, let us start with the following question. Why government support and policies are so important in the context of renewable energy? And the answer goes as follows. There is a large volume of literature on sustainability transition where the engineers and sociologists mainly and other social scientists work together to understand the uptake of different technology at various points of time. They also analyze the economic, the policy, the social barriers that are there in the uptake of a technology. And this kind of studies frequently points out that left to market selection alone, the radical innovations delivering the sustainability gain emerging as niches might lose momentum and die out if they are not looked after at the initial phase. This happens because there is always some kind of an incumbent technology. In our context, that is the fossil fuel based power generation. And we have also seen that many of the technologies associated with renewable energies are yet to be matured. So if these technologies do not get government support in order to, upskill and embedding in the whole technological domain, then it might face a severe challenge at the initial phase. And there lies the importance of government policies and support. Other than that, often this kind of new technology where the commercial viability is yet to be established, they also face the challenge in the form of market failure. Now, if you think about the renewable energy, there are two types of market failure that we come across. The first one is because of the absence of internalization of all externality that is being raised by the production of power through non-renewable or fossil fuel based resources. If these kind of externalities are not internalized, then the cost that is there in the market, that is the cost of output of fossil fuel based power generation out there in the market, that actually kind of that sort of does not reflect all the costs that the power generation sector has to take into account. Let us have a quick look at the theory in order to understand what do we mean by the internalization of externality. Now this is something this we have already come across in our previous lecture where we showed that if you think about the production, the prime objective of the producer is to maximize the profit, which is the difference between the revenue and the cost. And if you can see here, the cost is a function of Q, that is the output produced, which in turn is a function of the input that you are putting in the production process. So the profit indirectly is a function of the amount of input that you are putting in the production and the price of those inputs. Now the firm's profit maximization objective actually led us to the conditions where we found that the P, that is the market price, has to be equal to the marginal cost of the firm, which is equal to the marginal revenue. So coming back to this particular diagram, this upward rising part of the marginal cost curve of the firm was the supply curve of the firm. Now see what happens. If this is the supply curve as well as the marginal cost curve, then if the farm has to supply quantity equal to 50, then it can charge the price which is equal to 20. Now what we are trying to say is that this marginal cost curve or any other cost curves actually do not capture all the costs that the farm should have taken into account. For example, if you think about Q, that is the output being produced, what are the inputs that are taken into consideration? In case of power generation, the inputs that are taken into consideration must be the capital, that is the machinery, labor, the energy, that is the fuel that they are using, for example coal or oil or gas, and there are service sector inputs, there are other material used, etc. What is not taken into account is the cost of environment. See, environment does not enter into the production function as an input. But when the output is being produced, when the power is generated in a coal-fired power plant, this plant is actually also using some atmospheric space as the input, because it's dumping the greenhouse gas or the other pollutant that is being emitted as a byproduct of the process in the atmosphere. However, the farm is not paying anything for use of that atmospheric space. So some inputs are actually omitted from the production function. As a result, some costs are actually omitted from the cost function. This is called the ignorance of the external cost, the externality that the farm is generating. However, if this plant wants to internalize the external cost that it is generating in terms of probably environmental degradation or greenhouse gas effect and so on, then what happens? The input goes up. The amount of not the quantity of input, but the variety of input that one needs to take into account to construct the production function, that goes up. Now you have to incorporate environment as an input in your production function. You have to incorporate the cost of environment in your cost function. So your cost is going to go up. If your cost goes up, then this dashed line is no longer is your marginal cost curve. Your marginal cost curve goes up. When you shift from this black dashed marginal cost curve to this orange continuous marginal cost curve, then actually what you are saying is that to produce a particular quantity, more cost needs to be incurred by the farm. So this dashed curve actually was underrepresenting the cost of the farm. Now, if this is the new cost curve, which actually takes into account the external costs as well, then the scenario changes. What happens? In this case, if the farm wants to produce quantity which is equal to 50, which earlier with this broken MC curve it was being able to supply in the market at the price P equal to 20, it will no longer be able to do that. If the farm has to produce Q equal to 50 and supply that in the market, then the price needs to go up from P equal to 20 to this point. As a result, what we are trying to say that if all the external costs are internalized by the farm, then all the cost curves will actually shift upward, leading to a situation where the price of output in the market rises. Now, if you think about the renewable energy and the non-renewable or fossil fuel based energy, we have already discussed that there is a gap between the price of output that these two type of fuel are generating. So the cost of production of power through renewable is generally much higher as compared to the cost of production of power through conventional sources by the use of fossil fuel. Now what we can see is that although that is what the market price signals us, but we also know this market price is actually an underestimation of the true price of power that is being generated through non-renewable sources. So this is why we say, again we come back to this point, in absence of internalization of all external costs, the cost of energy generation from renewable remains high as compared to the fossil fuel in many cases, and this is one reason of market failure attached to the renewable energy. The second point is about the time of benefit. If the farms underestimate the future benefit of investment into the renewable innovation, then they will not be willing to invest too much of money from a macroeconomic perspective, and there will be some underinvestment in the projects. Now, why is that so? This is because the alternative to the renewable energy is the fossil fuel. Now, fossil fuel is depletable in nature. Now, the depletion will, take some period of time. Once we move on, as you just keep on using the fossil fuel, as we reach closer to the end of the stock of fossil fuel, it will become more and more expensive. And probably at that point of time, the value earned, the return from the renewable investment will be much higher. But that is not going to happen today or tomorrow or maybe in a decade's time per se, right? So oftentimes people do not understand the value that can be generated, the future stream of value that can be generated by investing in renewable energy today. So this is the other reason behind market failure. However, although these kind of challenges are there, we have already seen that the investment in renewable is rising continuously and the cost of renewable energy is actually coming down. So this is a good sign. Although there are a number of technology out there which are still to experience the maturity. If we really want to understand whether this technology is worth maturing and this can deliver some sustainable development goals, then it's important that this kind of technology and the renewable technology should have some policy support and other support from the government. So there lies the role of the government. However, you also need to take into consideration this fact that there is not a single policy that can fit all sides. So there is no such blanket policy available for the promotion of renewable energy. The policies that are required for the promotion of renewable energy may vary from technology to technology. So the policy or the support that is required for solar may not be similar to what is required for wind or may be very different from what is required for geothermal. Also, it may vary based on the location. So the kind of policy that you need in India may be very different as compared to the kind of policies that you need in New Zealand. There can be an umbrella policy at the national level. However, there can be sub policies at the state levels as well, depending upon the structure of the country. So there is a lot of complexity which is involved with the renewable power generation. However, one thing to note at this point, although we are kind of arguing that it's very important to shift from non-renewable to renewable power generation, it's also important to understand that there are practical challenges associated with the production of power with the renewable energy beyond a certain point. So it requires space, it requires certain resources which may not be available all the time, and renewable energy generation is also associated with some intermittency. So that you cannot expect to generate the same amount of power from the solar backed energy supply system because the amount of sunlight will vary not only during the day but also during the year. So there is some kind of intermittency associated with this renewable based energy, and again to give a support to this intermittency you need some fossil fuel based energy. So renewable energy, the shift to renewable energy should not be looked at as the only panacea of the whole problem. This is one of the medicines that we can have, but there are other things which needs to go hand in hand. For example, energy efficiency. On that note, let us look at the policies, the type of policies that we are going to discuss in this lecture. We are going to talk about three types of policies. One is called command and control, the second one is the price instruments, and the third one is the quantity instruments. Although they look like very different three policies, if you look closely, it's basically the genesis is two types of policies. One is definitely the command and control, and the other is market based. So, given the method of implementation and execution, these renewable energy policies can be categorized. What does the command and control policy do? This is more like a mandate driven policy. So some mandate will come from the state or from the regulatory authority, and if the entity who is supposed to comply to that mandate fails to do so, they have to pay a penalty. So there is of course a penalty structure associated with that. Either you comply, you don't pay the penalty, or you don't comply and you end up paying a penalty. The other thing is the market based mechanism. In that case, there is no hard and fast rule or there is no sort of penalty structure which is created. What does it do? It creates sort of market incentive so that the producers and the users of renewable energy automatically go for increased supply and increased demand for renewable. Now, under the market based policies, there can be two types of policies. One is supply, one is one is price incentive. Under the market based policies, there can be two varieties. One is the quantity based policies and the other is the price based policies. We start with the command and control policy. So there are certain mandates that are fixed and it's legally binding. So this is important. It's legally binding for the obliged stakeholders to comply with those kind of mandates. There we can come across, if we go through there are a lot of policies, that actually try to promote renewable and which are of this command and control type. If you have a closer look at that, you will see that there are two types of policies under the command and control. What are they? The first one is those policies which provide direct support to renewable energy. It actually leads to removal of all non-economic barriers and increases the demand for renewable. The examples are as follows. So as we have said that these energy policies to promote the renewable energy can actually span from all India level to the state level to even at a sub state level. We are going to discuss one policy which is a mandatory renewable energy generation policy under ECBC 2017. This is the Energy Conservation Building Code, and this comes in the form of a national policy. We are also going to look at some of the state policies regarding the solar hot water mandates. When we have this discussion, it's also important to note that although this command and control, the price instrument and the quantity instrument look like disjoint policies, they are not. Usually the policies have more than one component. So in our later discussion, we will see that the policies that we are trying to discuss under the quantity instrument has a kind of mandatory component in that as well. So oftentimes you will see that the policies are mix of one or two domains. So we start with the mandatory renewable energy generation provision under the ECBC 2017. So the Energy Conservation Building Code ECBC was designed to provide the minimum requirement for the energy efficient design and construction of buildings in India. It was introduced in 2007, and after that many changes and updates have come up as new knowledge has been gained. Now, this code is usually applicable to the commercial buildings or the building complexes with a connected load of 100 kilowatt or greater, or a contract demand of 120 kVA or greater. So these kind of building codes, they are applicable majorly in the context of big commercial buildings like hospitals or hotels or commercial area, things like that. It is yet to be implemented in the context of the residential sector. Now, what does ECBC 2007 say? It says that the buildings, the new buildings that are coming up and is of a particular format, that is of a particular size and has a particular level of energy consumption, they have to comply with this code, and they have to have a provision of generation of renewable electricity in the building. So it does not say that you start generating renewable energy in the building, but it mandates having the provision of it for the future. So there comes the mandatory part. If they do not have that, they do not have this future facility, then they do not comply with the Energy Conservation Building Code of 2017 in India. The implementing agency of this program is the Bureau of Energy Efficiency. We have already come across this agency, which is under the Ministry of Power, and this is one of the nodal agencies when we start discussing about energy efficiency, or in some cases also about renewable power. If you want to know more about this program, you visit the BEE website. I have provided the link here. Before we move on to the other program, just to have a quick point here, you see that energy conservation building codes are designed mostly to promote energy efficiency, right? So although it may seem that promotion of renewable energy is a different agenda as compared to energy efficiency altogether, it is not so. So all the energy policies, they all come under the umbrella energy policy of a nation, and they kind of go hand in hand. This is actually an excerpt from the Model Building Bylaws by Ministry of Urban Development, Government of India, which was published in 2006. If you look at this document and you see point number 10.2.4, it actually lays down the points related to installation of solar assisted water heating system in the buildings. And you see there are, from this A to G, there are different types of buildings that are defined. For example, hospital and nursing home, hotels, lodges, then you have hostels, then you have barracks, etc., the community center and so on. Here what it is saying that for this kind of building, which has a particular area and also have a particular load, they have to mandatorily install the solar assisted water heating system for future use. Again, they do not have to immediately start but over a period of time, it is mandatory that they start using the solar water heating system. Now for solar water heating system, what are the problems? Why is it so important to have a policy in place? Now it's not only for this, for many other technology as well. We have already discussed about a concept which is called the return on investment. What was that? So return on investment was basically the net cash flow of the company divided by the investment multiplied by 100. It actually gave us the number of years that are required in order to recover the investment in a very crude manner. Now, if the return on investment time period is very long, it actually shows that if I invest my money today, I might get some benefit, but it will take me years in order to recover that investment. And this return on investment for the solar heating systems are quite high. Therefore, you see that there is a general inertia from the part of private investment to come for the solar water heating system. And there comes the role of the government. It can either make it mandatory, or it can also create certain kind of incentive. If you look at this solar water heating mandates at different countries or different states, you will see that although this is a mandatory policy, it comes along with some kind of economic instruments like tax credit or direct subsidies, etc. So the quick information here is that Cyprus is the world leader in terms of capacity of solar water heating system per capita, followed by Israel. This is not only because of the fact that they get direct sunlight and radiation for a which is very significantly high, but it's also because of the fact that they have a very favorable policy regime and economic incentives in order to promote the solar water heating. More than 90% households are equipped with the solar water heating system in Cyprus. Okay, the next policy that we are going to look at is the indirect support to renewable. This is generated by putting some sort of a restriction on the fossil fuel based power generation. And one classic example is the coal cess in India, which was launched in the year of 2010. So India has a fund which is called the National Clean Energy Fund, whose objective is to fund the research and innovative projects in clean energy technology by levying a clean energy cess on coal. So it works in this way. So the indirect support that you get actually increases the cost of generation, cost of power generation from non-renewable sources, and it tries to create a level playing field between the renewable and non-renewable sources. Now, if you think of the coal cess, what is it doing? It's actually increasing the price of coal, which is the primary input of the power generation in the thermal power station. Now, if the input price goes up, the cost is going to go up, and therefore the price of electricity that is generated out of coal is also going to go up. And therefore it's not doing anything directly to the renewable energy, but in a way it is reducing the gap between the price of renewable and non-renewable energy. Now, why is it so important to have this kind of a structure in place? This can be legitimized in terms of in terms of the following argument, that we have seen in most of the cases the lower cost of fossil fuel based power is due to the fact that they do not internalize the negative externality that they are creating. Now, this kind of a cess is actually the price that was missing from the cost structure of the farm. So you can think that the coal producer is paying this cess because they are producing something which in future is going to occupy, I mean, the emission that will be generated from the production process of power from this particular coal is actually going to use some kind of an atmosphere space, and this is the price for that. This diagram actually shows that graphically. So you see, if this is the without the coal cess, if this is the price of the renewable, if this is the cost of the renewable power which is being generated, and this is the cost of the coal fired power plant, and therefore the price of the electricity generated from the coal fired power plant, you see that the price is that we are getting for the power that is being generated out of renewable is almost double that we are getting for coal. Once the coal cess is in place, the price of coal is going to go up. As a result, nothing although is happening to the renewable energy, the gap between the price of the electricity produced to the renewable and fossil fuel based energy, this is going to be decreased. Some fact about the coal cess in India, as I have mentioned, that it was implemented in the year 2010. at rupees 50 per ton. However, over time it was increased to rupees 400 per ton. During the period of 2010-11 to 2017-18, the total collection out of this coal cess is rupees 86,440 crore, and out of which only less than 30,000 crore has actually been transferred to this National Clean Energy Fund. The amount financed from National Clean Energy Fund for the projects is only 18% of the total amount that is collected as a coal cess. Rest of the fund is actually somewhat idle or not has been used for the proper purpose. There was a latest recommendation from the expert committee which suggested that you better use the fund which is available with the National Clean Energy Fund in order to compensate the states for any GST related loss and also to support the gas based power generation in the country. So their argument is that since this is a clean energy fund, and gas is much cleaner as compared to coal. Maybe it's not as clean as renewable, but it's much cleaner than coal because it has a low carbon content. Therefore, and there is a large capacity of gas-based power plants which is idle in the country, where the investment is sitting unproductive due to non-availability of domestic gas. Why don't we use this money to import gas from other countries and revive these gas-based power generation? So this is kind of debated, and there are arguments in favor of this. There are arguments against this, but this is one of the proposals that has been put forward. Next, we move on to the quantity-based instrument. As I have already mentioned, that quantity-based instruments and the price-based instrument, both of them, they are market instruments. Let us have a quick look why this price and quantity instruments cannot be implemented together. So either the government fixes the price and let the market decides the quantity of renewable energy that is being generated, or on the other hand it fixes the quantity or mandates the quantity and let the market come up with the discover the price. Now the question is, why can the government not mandate both price and quantity? The answer is as follows. Again, we go back to this previous diagram. Here you see what is happening. This broken line is upward rising line is the marginal cost curve of the farm, as well as this is the supply curve of the farm. Now, if the government actually says that the renewable, so if we assume that this is the supply of the renewable energy by the farm, then if the government fixes the price of renewable energy or fixes the electricity produced from renewable energy at rupees 20, then given the supply curve, the farm will produce and supply quantity is equal to 50 measured in suitable units. However, the government cannot simultaneously decide some price equal to 20 and some quantity which is other than 50. Then the farm has to deviate from its supply curve, which will actually violate their profit maximizing condition, and that's not quite an optimum situation for them. Therefore, the government either says that it's going to fix the price at 20 and let the market discover the quantity which is eventually going to be equal to 50, or it can also say that at the end of the day I want to produce renewable power which is equal to 50 in some suitable units and let the market discover the price, and given the supply curve the market discovered price will be P equal to 20. So this is the reason why in the market based instruments you see either the price is fixed or the quantity is fixed. So we start with the quantity based instruments where the targets are in terms of absolute quantity of the renewable energy production. Here we are going to discuss about three types of policy instruments. The first one is called the Renewable Purchase Obligation, RPO. This is also known as Renewable Portfolio Standards, or RPS, depending on the geographical location of the countries. Usually the Renewable Purchase Obligation, or the RPS, it is implemented along with another instrument which is called the Renewable Energy Certificates, or REC. There is a third kind of policy that we'll also have a quick look at. This is called the Renewable Regulatory Fund, This is not exactly same as quantity instrument, but it also addresses the quality issue of power supply. So we start with the renewable purchase obligation. This is one of the major instruments, renewable energy policy instruments that are implemented in India. This is sometimes this is called to be the backbone of the policy instruments of Indian renewable energy system. What does it do? It basically mandates the introduction of a certain percentage of absolute quantity of renewable energy capacity or generation at some unspecified price. So therefore, it may or may not be technology specific. So it can either say that this kind of, this certain percentage of absolute quantity of renewable energy, sometimes it mentions that it has to come from solar, or it has to come from wind, or sometimes it's pretty general and it says that it has to come from the renewable. So what does it exactly mean? It means, for example, that 20% of renewable standard or 20% of solar purchase obligation implies that energy suppliers, or all energy suppliers, they have to provide power to grid to meet such standard in order to ensure that whatever power they are supplying to grid, 20% of it is coming from the green sources, 20% of it is coming either from the solar, or from, in case of solar purchase obligation, or from any renewable sources from the renewable purchase obligations. Now, if all energy suppliers, they have to comply to this kind of a policy, it looks more like a command and control policy, because there is no market element that you can see. Now, what will these people do? They have to probably set up a small solar plant somewhere and produce the solar energy and supply it to the grid. But it might be very, very expensive for them. As a result, this kind of inflexibility, which is a typical feature of the command and control policy, leads to certain kind of sort of inefficiency in the whole system if RPOs are implemented as the standalone instrument. The source of energy, inefficiency arises out of the fact that this policy, if operated alone, has less flexibility, and renewable energy certificate is the complementary instrument that is provided or implemented along with RPO to get rid of this kind of inflexibility of the system. So what does the renewable energy certificate do? The renewable energy certificate will do the following. These are the features of renewable energy certificates. If I get one renewable energy certificate, it means that I have produced one unit, that is 1 megawatt hour of electricity, and I have generated it using the renewable energy. This is a non-tangible and non-tradable commodity at the first place. So if I produce the renewable energy, I am going to get the renewable energy certificate from the authority, right? Now you see this renewable energy certificate, it has two attributes present in that. One is that 1 megawatt power has been generated, and the other attribute is that it has been generated from renewable energy. Now these two attributes are called these two attributes can be bought and sold together, or they can be bought and sold separately. So if I am producing 1 unit of energy with the help of 1 unit of energy with the help of some renewable technology, then what I can do, either I can sell some of the discoms both these attributes together. So this discom has to comply with a target of 20% renewable purchase obligation. So what I can do, I can sell both these attributes, this 1 megawatt of power as well as this renewability attribute to the discom. However, it might also be the case that the discom doesn't want to buy the electricity. It has enough electricity, it doesn't want to buy the electricity. What it wants to buy is only the renewability attribute. So that is also possible. So I can sell only the renewable attribute to the discom, and the power that I have generated, I can sell it to the grid, or I can just sell it to some other consumers. So that is possible. This kind of disjointment is possible. If this kind of a policy is there, so that is, if the renewable energy certificates are introduced along with the RPO, it gives the flexibility in the system, and it sort of ensures that the same target has been achieved at the least cost possible. So here I would like you to stop for a while and think about the policy that we have also discussed with respect to industries, which is the perform, achieve and trade. Now what was there? There the government mandated certain energy efficiency, the specific energy consumption targets for the industries. And the industries have to achieve those specific energy consumption targets. This is more like a mandatory policy without any market instrument, which resembles the functioning of RPO. Here also the energy suppliers, they have to achieve some target, some compliance, 20% of power from the renewable sources. However, PAT was not only about achieving a particular threshold of specific energy consumption, it was also about certain kind of market mechanism. So if you recall the discussion, there we said that if a particular industry fails to comply, fails to achieve the target of specific energy consumption, which may happen when the industry finds it to be very very costly to upgrade the technology in a more energy efficient manner, and it may well find that it's better not to invest in energy efficiency, but it's much cost effective to buy the certificates from the overachievers under the perform achieve and trade. Exactly the same thing is happening here. Although the target is to supply 20% of renewable energy, it's not mandating in a sense saying that you yourself don't have to produce this amount of renewable energy. If you find it cost effective, you can produce it on yourself, or if you don't find it very cost effective, then you can buy it from somebody else as well through the renewable energy certificates. So you see this renewable energy certificate, the ESAT that we had been discussing, they all have sort of a similar property. So it kind of gives a flexibility and cost effectiveness in a mandatory policy. Okay, so this is a combination. In a way, you can say that RPO is basically a command and control policy, but RPO along with REC, this is a combination of command and control policy with and combination of command and. So what you can say that when implemented together, this renewable purchase obligation and REC, it's a mix of command and control policy and the market driven policy. Let us have a quick look to understand in more details how the renewable energy certificate works. So here I have chalked out some 5 stakeholders. One is the conventional energy producer. The second is the renewable energy producer. Both of them, they can provide electricity to the grid. There is a regulator who is actually issuing the energy, the RECs, that is renewable energy certificates, and there are customers of the discoms. So how does it happen? How does the function of renewable energy certificate happen? Once the renewable energy producer produces electricity, the regulator issues the renewable energy certificates. Now it has 2 attributes. The orange line actually represents the attribute of electricity, and the green line reflects the attribute of renewability. So it has generated certain amount of energy and from renewable sources. So these 2 attributes are bundled and given to the renewable energy producer. So what does the renewable energy producer do? Along with the conventional energy producer, it can supply the power to the grid. So this is one option. The renewable producer can also supply the power directly to the customers. But this is one of the examples. From grid, as they sell the electricity to the grid, the discoms actually selling this to the customer from the grid. Now see that this renewable energy producers, once they have sold the power to the grid, they are left with the one attribute only. They are left with the renewability attribute. Whom do they sell the renewability attribute? They have multiple options depending upon the exact design of the policy. If the conventional producers are forced to show that they are also producing from renewable sources, then they can sell it to the conventional energy producer, which is oftentimes not the case. In other cases, the discoms may be under obligation that they have to show that 20% or 25% of what they are selling is coming from renewable energy. So this renewability attribute they can sell directly to the discoms, or they can sell directly it to the consumer who wants to comply to such kind of a mandate. So this is how it works. Once this renewability, see, once the power is sold, it's sold, right? Anyway, it's not there with you. So once the renewability component or renewability attribute is also sold, that is the time where the renewable energy certificate actually retires. So it's no longer in existence when both the attributes are sold in the market. Let us have a quick look at two of the policies related to this RPO and REC. So in India, state electricity regulatory commissions usually implement the this SPO, which are the solar purchase obligation. So instead of calling it RPO, we are calling it SPO because this is specific to a technology. So the obligation is that 20% has to come from solar power. So it cannot be wind or something else. If we look at the policies of Tamil Nadu, you will see that solar purchase obligation, that is SPO, is mandatory at 5% for heavy energy users such as the special economic zones, the information technology park, the telecom towers, the educational institutions, the industries who are guaranteed with 24/7 power supply, and the buildings which are much bigger with a build up area of 20,000 square feet or more. So all these entities who are bigger energy consumers, they have to comply with a mandatory target that 5% of their energy has to come from renewable, not only renewable, from the solar purchase obligation. If you look at the Maharashtra Renewable Energy Policy 2015, you will see that a total of 5,000 megawatt capacity of wind energy project was planned to be commissioned under this policy. Out of that, it was decided that initial 1500 megawatt hour would be used to fulfill the renewable purchase obligation of distribution companies, and the rest of 3500 megawatt capacity of wind project can be utilized for open access for interstate or captive consumption or for REC as well. So once the power is produced in the in the windmills, the initial 1500 will actually go to fulfill the renewable purchase obligation. There are four stages of this renewable energy certificate mechanism: the accreditation, the registration, the issuance, and the redemption. So designated state agencies, they have to accredit and recommend the renewable energy project for registration. Once they get the recommendation, they go for registration. After verification of all the documents and everything, the central agency registers these renewable energy projects. Once they are registered and once they produce the renewable energy, within 3 months duration of the production of renewable energy, they are eligible to apply for the renewable energy certificates. So the same central agency will issue the renewable energy certificate to this eligible entity after verifying the claims made by them. The final stage is redemption, where they can sell these two attributes as we have discussed, the electricity as well as the renewability attribute. So this usually takes place on the power exchanges. There are two power exchanges. These are the same power exchanges that dealt with the buying and selling of ESARTs in the context of PAT. So this is the Indian Energy Exchange and the Power Exchange India Limited. So these are the four stages, how it goes on. It's everything goes on online, and the system is being more and more customer friendly as we move on. The final one under the this particular instrument is the Renewable Regulatory Fund. This is not directly associated with the RPO or REC obligation. This is a different kind of policy instrument that is often implemented. This is basically a penalty and incentive structure which is created in order to create or ensure the stability of power supply through the renewable sources. This is especially applicable in the context of wind and solar power projects in India. See, this as a context. I mean, when we talk about the renewable energy, this comes with a certain amount of intermittency. And there are certain uncertainty with regard to how much energy will be supplied by these renewable energy projects on a day-to-day basis. But this is a very important information that the discoms need to know, that how much power will be there in the grid. So what they are asked under this RRF, this specific, I mean the bigger wind and solar generators are mandated to undertake the forecasting and give schedule of their generation on one day ahead. So they are responsible for forecasting with an accuracy of at least 70%. So whatever they forecast, if they are within a 30% limit of that up and down, then there is no penalty applied. So the forecast is assumed to be pretty much accurate. However, if their forecast goes beyond the this deviation of plus minus 30% of the schedule, then there is a penalty structure which is applicable. So what does this instrument do? This actually provides a kind of stability to the power supply system in order to achieve the quantity targets. If you want to know more about this renewable regulatory fund, I would encourage you to go to this website and check this content.